Going to take a look at the final example here, and the notes will show the written down stuff. I may put that into the notes, or I might kind of bring the notes to you in a little bit. But for right now, we're just going to look at creating a quadratic equation which contains the points 5, 12, 13, 20, and 20, 25. So what that will do then is, again, we're going to do the same thing that we did previous. And again, I'm just going to move my screen over here so you can still see me. We're going to start off with making a table. And so we're going to put our points in there. So 5, 12, 13, 20, and 20, 25. Okay, so there's my 3 points. Can't really see them here. I'm going to have to zoom out a little bit. There we go. There's my 3 points. They kind of look a little bit like a line, okay, which in essence they are, but you might be able to see there's a bit of a curve there. So it looks like they're kind of curving up, and it's going to form maybe something like this, because it just looks a little bit like that. Okay, so based on what I can see, this is the curve that we're going to form, something like that. Could be completely different, but we're gonna give that a shot, and hopefully that works. Okay, all right. So I'm just going to erase my pen markings there. Now, these 3 points are there. If I want to come up with an equation for that, I'm going to have to use a regression. There's none of my other ways, factored form or vertex form, which I could actually use, because I don't know if one of those is the vertex. Might be, might not be. The top one might be the vertex, might not be. I kind of assume it's going to be a little higher. But if we use a regression, we'll get the exact equation out of there. So y1, and then the little twiddle sign there. Again, remember, that is right beside the number 1 key. We do shift and then that. And then we do ax1 squared. And you notice that one that we have right there, not even close at this point, because we haven't given all the information yet. bx1 plus c. And boom, look at that. Okay, it goes through all 3 points really nicely. Okay, which matches up perfectly. We have a vertex right here. It's opening down, and our equation is going to be using the a, the b, and the c from right here. So we're going to plug those in to our equation and create an equation using those 3 values of a, b, and c. Now this graph right here, okay, has everything that we need in there. And so I'm going to go and type that in. All right, so in the notes, I've already put it in, okay, right here at the bottom. I have y is equal to negative 0.019 x squared plus 1.34 x plus 5.76. And that's the equation. It's done. That's our quadratic equation. Now you might notice something. I am rounding all of my values. On decimals right here, it's going to give you big long values for a, b, and c. I will always round to 2 decimal places unless the first one is a 0. So you'll notice negative 0.019. I'm using the 3rd decimal place, using 2 numbers when at all possible for my equations. Okay, so 0.019 x squared, not just 0.02. Try and keep it somewhat more accurate, but for the most part, we're going to round to 2 decimal places. It's important that we understand where these pieces come in and how we go through and solve them. So plug in our 3 points, at least 3 points, use our regression, and our regression will then immediately pop up what the line looks like. I am going to do one more video coming up after this that deals with if we have multiple points or trying to find a line of best fit, and we'll go through that in just in our next video. Don't worry too much about that one, but if you want to watch that, it just gives us a bit of an idea of how things work out a little bit better.